This conference will now be recorded.
All right, so thank you everyone for joining today, and thanks for bearing for a few minutes as it got a little late. So to start with, I usually start with introductions, but as we have a lot of people and we have already spilled out 10 minutes, we won't. I will just introduce myself and then we will run into the session directly. So if you have any questions at any given point, you can either just put it in the chat. I will try to go ahead and respond to that, or else you can voice it out and just ask me. So, a quick introduction about myself. I have been working with one of the MNCs as a technical architect, and it's been 12 years that I am working in healthcare industry. I worked on various kinds of interface implementations and interface engines like Mirth Connect, Rhapsody, Integration Buddy, and little bit on Ensemble as well as Cloverleaf. So in today's session, we are going to take a look at the introduction of HL7. So this training is all about learning HL7 and also learning Mirth Connect. So our entire training is divided into two sections. First would be everything functional about HL7, where we'll be taking a look at what is HL7, how did HL7 name come up, and what are the different message types, different segments and all. Next, we'll be taking a look at the technical part, which is to go through Mirth Connect and learn about Mirth Connect from the beginning, understanding all the options that are available for us to go ahead and implement an interface, and also to learn how to create an HL7 message out of the data that we extract from database and how to interpret HL7 messages, write complex code to build transformations, which is to manipulate the data and also to work on filters. So that will be the second part of the training. So in today's session, we are going to take a look at an introduction on HL7. Where do we hear this term? Where does this come into picture? And we'll take a look at basics of hospital workflow, which actually stands as a blueprint for us to see what kind of message types or what kind of HL7 message types are generated at which point of time. And we'll see why do we need HL7 and how the name has been arrived. And we'll also see what is an interface, how an interface is built, what is the role of HL7 in interfaces, and what is interoperability and HL7 message structure as well. So before jumping into the actual hospital workflow, we'll see what are the few general terms that we need to be aware of before jumping into the training, because we'll be using these acronyms a lot while talking about functional parts of HL7 and all. So PM is nothing but practice management. This is usually a software application which is used by the front end hospital staff, or usually the receptionist, to go ahead and register the patients and capture their details, their name, date of birth, and their gender, and then their guarantor information and then insurance information. So as soon as we arrive at the hospital, they take all of these basic details, right? So those details are saved in this software application. Not only that, PM application is also used for scheduling the appointments for doctors of different departments, and also once the entire appointment cycle is completed, it is also used for billing system. In few hospitals, you see that bill is being generated by the PM system itself. So again, whether the PM needs to be a billing system or not entirely depends on the hospital workflow. So right now, all that we need to know is it is a software which is used to register patient and schedule appointments. Next, we have electronic health record, which is the clinical software which is used by doctors. Doctors usually use it for tracking what all appointments they have for that particular day, and also this is used to store the entire clinical history of the patient, what all appointments he had, and what are the medications that he have been provided, what patient is present in, the diseases that he have been diagnosed with. all of that clinical information, electronic health record module. So this is also another software application used by the doctors. Next, hospital information system. So all of these things put together, whatever falls under whatever softwares we use within the hospital, billing system or PM system or EHR system, all of these put together are called as hospital information system. And then LIS is nothing but lab information system. So this is specific to the lab. Lab will have their own application, and in that application they will manage their own orders and results, where for example patient is diagnosed or patient is given certain uh, test to be done, then all of that test information and the results information will be stored in the lab information system. And then we have ICD. ICD is nothing but International Classification of Diseases. So right now we are using ICD version 10. So this is nothing but a book or library, you can say. It is a book which will have all the list of codes for each and every disease that is out there in the world. So even uh, all the diseases, whether it is malaria, or typhoid, or Ebola, or latest COVID, all of them will have a certain unique ID or a unique code that is called as an ICD-10 code. So this will list out all the diseases. Next, we have CPT. CPT is nothing but current procedural terminology. Same like ICD. ICD is used for listing out the diseases. CPT is used for listing out the procedures that have to be performed in our on certain patients. So all the CPT codes will be listed out as in one book. So that will have all the list of procedures that has to be performed. Next, CCD. CCD is nothing but continuity of care document. And when we look at continuity of care document, it is a kind of a document which has complete list of or complete health record of the patient is what we can say. So it will contain what all the allergies the patient has. It will contain what all the vitals that the patient had during that particular patient visit. And also it will have the entire information about what medications he has taken and what is his main complaint for the visit, and so on. So it will have entire clinical history of a patient. Usually it is given to the patient during discharge so that he can have his history of what has happened to him. And CCDs are used in some other technology called as some other platform called as HIE, which we'll be talking about. In our training, we'll be talking about HIE in the last session, where I'll give you bird's eye overview of what is HIE, how we use CCDs with respect to HIE and all. So HIE is nothing but Health Information Exchange, which is a common central body for a certain region in the US, where where all the hospitals share their data with HIE and form a central repository of data so that they can go ahead and share that information with government as well as different hospitals. Whoever hospital needs any data of any patient, HIE will go ahead and serve that purpose of sharing that data to different hospitals. Next, that IHE. IHE is nothing but Integrated Health Enterprise. This is a standard specification which is used to interact or which is used to develop interfaces with HI. So you'll be seeing about IHE whenever you are implementing an interface with HI. So now next we will jump into uh, the hospital workflow. This could be very basic, but the reason why I go back to hospital workflow or introduce this is to make sure that we all know that this holds as a blueprint, and understanding the workflow of any hospital is very important, because that is where we will have the events being triggered. So when we talk about HL7, we will always relate it back to hospital workflow, and then we will try to understand how these real-time scenarios that we have in hospital workflow reflect in terms of HL7 data. Okay, so let us quickly go through hospital workflow. So as we all know, when we visit the hospital, we first visit the reception desk and we provide our details. They will ask her whether we are visiting there for the first time or have you been there earlier. And then once they provide their basic details, we see that they capture all the basic details like name, date of birth, gender, and our SSN. And in case if we have guarantor, they will collect guarantor information. They will also collect um, insurance information and all. All of these information put together are called as demographics. So this is the term that we use in healthcare IT. Uh, we call them as demographics, all the basic patient details. Once that is captured, then the receptionist would ask which doctor they would want to meet. Definitely, the patient has been there for visiting certain doctor, so they will provide the doctor's information and get an appointment schedule. So as soon as the appointment is scheduled, appointment will flow over to the doctor's desk from PM to the EHR system. So PM is the, as I said in the previous slide, we have seen PM is nothing but the front-end application software. So PM will send over the data to the EHR system, which is doctor's system. And usually we quote doctors as providers in healthcare. So which is why we are seeing the provider tab here. So once the appointments and demographic information flow over from PM to EHR system, which is nothing but from the receptionist desk to the doctor's desk, next patient will go ahead and meet the doctor. So now this situation where the patient is meeting the doctor is usually termed as encounter, where patient will discuss with doctor about the problems that they have, and they will they will go ahead and just inform what issues they are facing. Doctor will try to go ahead and diagnose the patient, and if doctor is able to go ahead and figure it out just by looking at the patient what the problem is, then that's well and good. But in most of the cases we see that doctors wouldn't be able to figure that out just in the first go, and they will go ahead and place certain orders like blood test, thyroid test, and so on. So they will place the orders and they will send out information to the lab. So even these orders will flow from EHR system to the lab information system. Okay, how they will flow and all that is the backend architecture, which we'll be talking in a while. But just we all that we need to understand is order information is going from EHR system to the lab information system. And from lab, once the lab uh, gets all the order details, patient will visit the lab. Lab will go ahead and get the test done for the patient, and they will respond back with the results. So the results will flow back from lab to the EHR system, and doctor will be notified that there is a result for that patient. Then doctor will review the results, and once the results are reviewed, he will go ahead and suggest the treatment and provide prescription on what all medicines that patient has to use. And patient will go ahead to the receptionist and pay the bill if he had to, final bill if they have to, or else if they have insurance, they will just leave the hospital so that a receptionist will go ahead and raise the claim with the insurance company. So this is the hospital workflow, and the finally the charges will flow back either from lab or from provider, which is nothing but the EHR system, to the receptionist. And as I said, receptionist will go ahead and raise the billing or raise a claim with the insurance company and get that claimed. So this is the hospital workflow, and most of the events or most of the HL7 messages that we are going to talk about will always relate back to this particular workflow. This is the generic workflow that what we have seen. Depending on the hospital size, hospital structure, and hospital's uh, information, we will see that there will be a lot of changes in the workflow in the real time. So we will see that in future. All right, so next we will see what is the importance of a common language being there, and what is the role of HL7. So first we will take a look at one quick example, or let's say we have three different people from three different countries. Okay, let's say we have a guy from US, we have a guy from India, and we also have a guy from China. So in case if these three people have to communicate with each other, let's say US guy have to communicate with, they don't have a common language, and so in case if the Indian guy has to communicate with Chinese guy, then he has to learn Chinese, or else if you have to communicate with the US guy, he has to learn English so that they can communicate with each other. If these three people have to communicate with each other, they have to go out and learn each other's language, which is time consuming process, which is a tedious process. And also, we will never know how many number of people we might have to communicate with. So if these are just three people, each of them have to learn two different languages, and they will end up in learning both the languages and communicating with each other. But just in case, let's say we have 10 people out there from 10 different countries. Now they will have to go ahead and uh, learn the language of each of them. And that is again a huge process that they have to go through. So they have come up with the thought of having a common language so that every one of them will learn that common language. And once they learn that common language, it is easy for each one of them to learn that common language and communicate with each other. With that approach, they are going to have a solution that they don't need to go ahead and learn all the languages. They just need to learn one other additional language from apart from their native regional language that they have. They have to learn another additional language, and with that language, everyone can communicate with each other. So we see that in today's world, English is a common language that we use to communicate all over the world. In the same way, when we talk about the electronic software systems in healthcare, we have similar challenge. So we'll just try to look at what the challenge is. So if you look at the screen, we see that practice management is a software application which we have seen just now, where all the patients are registered and all the details are captured. And electronic health record is something that the doctor deals with. Information from practice management has to go to electronic health record. So from the example that I gave, we are talking about languages, but here we will be talking about the backend databases. What is a backend database? So every software application that we are going to deal with will have a backend database where the data is actually stored. For example, you are looking at your Gmail. When you open your Gmail, browser is just your application which is showing up the data, but the actual data is stored in a database which is on the Google server, which is just reflecting the data that is stored in the Google server on your Gmail page. In a very similar way, practice management is just a software, and it is just reflecting the data or showing the data which is present in the PM database. Same applies to electronic health record. They have their own EHR database where the entire data is stored. EHR is just acting as a mirror or a reflecting software which is reflecting the data from database. Same logic applies for any software application, not just these three. Any software application will have that architecture. That being said, now in the previous hospital workflow slide, we have seen that as soon as the details are registered in the PM system, it has to flow from PM software to EHR software so that doctor can know which patient has come in, and doctor can know what are the appointments that he has for that particular day. So in order for that thing to happen, the data has to flow from PM to EHR, right? So when I say that the data has to flow from this PM database, which is the actual residing place for the data, to the EHR application database. So actually, when we talk in real time, then the databases has to be connected to each other. And in order for that to happen, there should be an integration engineer who should extract the data from PM database for the patient who got registered just now and send it over to the EHR. And EHR integration engineer should go ahead and and the same integration engineer should go ahead and insert the data into EHR database. Now, this is very tedious work for the reason that the integration engineer, let's suppose he know everything about the PM database, which is kind of regional language for him. Now, when he has to insert the data into EHR database, he has to learn the entire architecture of EHR database and then insert the data into the EHR database. Or else he wouldn't know which table or which architecture he has to, I mean, which table data he has to insert the data into. So he has to understand the entire database architecture of EHR, then only he'll be able to go ahead and transfer the data correctly. So now he is ending up in learning another database architecture altogether. Now let us say if it is one database, then that's fine. But when we talk about real-time interfaces or real-time integrations, there will be more than one database where PM system has to integrate with, or EHR system has to integrate with. And the integration engineer cannot go ahead and keep learning the architecture of all the database that he has to integrate with. So this has bring up a challenge. So the challenge is apparently there should be a better way to make this data transfer happen. So, and there was no common medium or common messaging standard which they can use to go ahead and transfer the data with. That is when they have come up with the solution of having HL7 as a common messaging standard or common medium of communication between all these three entities. So what happens? How did this solve? How did this HL7 solve the problem? So what happens in HL7 is when practice management has to send the data to the HR system, the integration engineer on the practice management side will extract the data and convert that to HL7. Instead of he inserting the data into the HR database, he will just convert the data into HL7 message and he will send it over. Now the integration engineer on the HR side has to go ahead and consume that HL7 message and insert the data into database. Now HL7 being a common medium of messaging standard or common language, we can say, he understands the EHR system understands, or EHR side integration engineer understands HL7 because that has been decided as a common medium. And he will interpret that HL7 message, he will insert the data into database. Same goes with the lab. Now, all the parties, whoever is involved in this ecosystem of integrations or ecosystem of these applications, all they have to need to know is HL7. They have to understand HL7 so that they can send their data in the form of HL7 or receive data in the form of HL7. So now that they understand HL7, they will be able to go ahead and interpret that, and they will be able to go ahead and insert that into the database. Okay, so that is how HL7 has solved the problem of communication between different applications in the healthcare industry. So later, so HL7 has started in 1980s. So we'll just take a look at the history in a while. But now that we have seen how the data is being transmitting in the form of HL7, we'll just try to quickly understand what is an interface. So since beginning, I'm saying that data is traveling from one system to another, from PM to EHR, EHR to lab, and from lab to the PM again. And we are also seeing that this transfer of data is happening in the form of HL7. But one thing that we need to understand is this is happening through an interface. So what is an interface? An interface is nothing but a bridge or yeah, we can say it as a bridge or a tunnel, which is actually connecting the PM application with the HR application. Okay, so this will construct a bridge so that data can be flown from PM to EHR in the form of HL7. So that is an interface. An interface is nothing but a bridge which is going to transfer data from one system to another. Here I have taken an example of PM and EHR, but it doesn't matter. You can have connections or you can have integrations between any application, either it's PM EHR or EHR lab or lab or PM or anything. So one important thing to note here is in the previous slide we have seen there is a challenge for the integration engineer to understand the architecture of the database of the other side. With HL7 that has been solved. So now it doesn't matter what kind of database that application has, whether it's an SQL database or whether it's a flat file database, whatever it is. Apparently, we are going to send the data in the form of HL7. So it is just a direct connection between the applications where it will extract the data from database, convert to HL7 and send it over to the HR system. Okay, so we'll just have a quick
Hey,
summary.
Dixon, sorry,
So
quick question here. Can I interrupt? Is that
sure,
okay?
sure. Yep,
So,
go ahead.
so the practice management software within
Hmm.
itself will have an some kind of an interpreter or whatever it is you call. It will have a built-in software that would convert the message to be an HL7 before it can send. Is that what you're getting at?
Yep. So you can say two ways. One, we have some old softwares which have their built-in integration mechanism which will generate HL7 and send it. That is one way. We have another approach called as having an interface engine which will actually perform that work for us, which will extract the data from database, generate HL7 and send it over. And it will also receive HL7, interpret it and insert that into the database. So that is called as Mirth Connect interface engine, one of the interface engines out there in the market. There are many softwares of that kind called as Rhapsody, Cloverleaf and all. So in our training, our second part of technical training will include that technical aspect, how we go ahead and use Mirth Connect interface engine to perform this entire work,
Oh, I see.
extract data and generate HL7 and send it over to the other side, and also receive HL7, interpret them, and how do we insert them into database and all.
Okay, perfect. Thank you.
Yep. So we'll have quick um, summary of what HL7 is. So as we have seen, HL7 has emerged as a messaging standard which is used in healthcare. So in all over the world, whichever country you go, if they are transmitting the data in the form of in healthcare industry, then they will be transmitting in the form of HL7 itself, because that is the most accepted medium of messaging standard. And as I said, we will see that these transactions between all the healthcare applications, and the name itself has arrived from the OSI layers, which we'll be taking a look at in the next slide. But the name has been arrived from the fact that this HL7 message operates at the seventh layer of the OSI model. So we'll quickly take a look at what is OSI model in the next slide, and we will have a deeper look at it, how the name has been arrived at. And more than 28 countries are using it, and more countries are being added day by day. We see that in Argentina, Greece, Australia, Finland, USA, UK, India, South Africa, and most of the UAE countries are also using HL7 today. So we'll quickly see how the name has been arrived. So I'm not sure how many of you know what OSI model is. We will not be taking a deeper look at it. I'll just quickly brief on what this does. And if you want more information, you can just go ahead and Google it and take a look at it. So OSI is nothing but Open Systems Interconnect. This has 7 layers. Now I am presenting this information on my screen, but you are able to see it on your screen. How is that possible? Um, because I'm sharing something which is a soft data or soft application which cannot be touched. But we see that the data is traveling through the internet cable that we have, and data is flowing from my system to your system that you're seeing in. And in order for that to happen, there are 7 layers from the application that you are seeing till the point it reaches your Ethernet cable. You connect your Ethernet cable to your laptop, right? Laptop or system. So this Ethernet cable at the point where you connect it to your laptop is called the physical layer, which is the last layer. And whatever seeing on the screen right now is the first layer, 7th layer, application layer. Okay, so the first layer is the physical layer, at the point of your port where you connect your Ethernet port, and the 7th layer is the application layer which you're seeing on the screen, and there are 6 other layers in between. So what is happening is the data that I am presenting on my screen is being converted into packets when it is passing through all of these 6 layers. And finally, these packets are generated and those packets enter the Ethernet cable and they will be transmitted to your system through the internet. So we all know that internet is nothing but interconnected cables that we have through which data is being transmitted in the form of packets. So OSI layer is the one which will actually enable that to happen, where the application or whatever data that we want to transmit will be converted in the form of packets using this concept. So you can research more about it. Each layer that you're seeing here has different significance on how the data is being converted into packets, and finally it will be sent through the physical port and through the physical wire that we have. So what is the importance of OSI layers with respect to HL7? When we are talking about HL7, we are manipulating the data or extracting data from database and constructing an HL7 message using an application, using using an interface engine software. So as we are operating at 7th level, which is nothing but the application layer, the number 7 has been given. So HL7 means nothing but it is health level 7. So as we are operating the data, health data at 7th layer, it is called as HL7. That is how the name has been arrived. So next we'll take a look at the next slide. We'll take a quick overview. So like any other language, HL7 has its own grammar and syntax. That being said, now when we talk about English, English has its own grammatical syntaxes. Full stop is to end, terminate a sentence. Comma is to give a pause, and quotations to specify certain specific quotes, and so on, right? So in the same way, HL7 has its own language and its own syntax, which we'll be seeing at the in few slides ahead. And HL7 as a book or as a language or as a messaging standard has many different versions. So currently we have version 2, version 3, and even in version 2 we again have version 2.3, which has been widely accepted, version 5, which version 2.7, 2.8, and so on. And version 2.3 was the most implemented out of the all versions that we have. It has 12 chapters and 5 appendices, and there are more than 50 data types. But by the time we reached version 2.8, we have 90 data types, out of which we'll be definitely taking a look at few in upcoming sessions. And we have more than 80 message types. So message types may be new for you to understand now, but as in when we proceed with the training, you will definitely get to understand what message types are. And there are more than 86 event types. So we'll also be looking at what event types are during this training. So let us quickly take a look at what is FHIR. So FHIR is nothing but it is a history. I mean, it has a history right start. Sorry, we'll be taking a look at HL7 first, and then we'll understand about this FHIR. So HL7 has started back in 1980s, and it has been given a good form in 1997. Even it has started in 1980s, forming an HL7 body which can go ahead and express its have a standard form of HL7 language or HL7 messaging standard has been done in 1997, where version 2.3 was released. From then we see that we have 2.3.1, 2.5, 2.7, 2.8, and 2.3 in 2015. So many asked me a question about 3 specifically. I mean, whoever has an idea of HL7, they asked me about 3. Version 2 and version 3 have different architecture altogether. So version 2 has been used since 1980s, as I said, till 2015. Version 3 has been introduced in 2015. Now, over a period of last 25-30 years, people have been using version 2, and suddenly switching to version 3 was not feasible. There are many reasons why people did not turn into version 3 or switch to version 3, and it was not very much widely accepted by the industry for the reason that it is not adding any new value, because they have already, I mean, most of the hospitals already have interfaces using version 2, and there is no additional value with converting to version 3. Only a handful of clients have converted to version 3, and even I see few of them are planning to go back to version 2 itself. Now, that being said, FHIR has been introduced in 2016 around that time. So FHIR is nothing but fast health interoperability resource. And another question that comes up is FHIR and HL7? So FHIR again has a different architecture altogether. FHIR has been introduced with the concept of building APIs, and the way FHIR deals with is totally different from the way how HL7 is being dealt. HL7 is used for developing interfaces based on an event, whereas FHIR is used to develop an interface or develop integrations based on request and response. So both are totally different. And few of them also ask me whether FHIR will replace HL7. We never know. As of now, in the next 5 to 10 years, we are not seeing that because the architecture is different. And how do we convert HL7 related interfaces to FHIR? As of now, we don't know. With this never-ending change in the technology that we have, we can never predict anything as of now. But for the next 5 years or 10 years, no, there is no scope. It might take time. It might take time, a lot of time for that to happen. So what are the advantages of HL7? As we know, HL7 has solved a lot of problems, especially with respect to the integration between two different systems. It has a lot of advantages, especially it will enable the ability to share the medical data, demographic data, billing data between different applications. We have data transfer happening in the form of messages. No special tools are required if the interface engine is integrated within the application. If not, there is only one tool that has to be looked at, which is nothing but our um, integration engine. And then code is in the form of ASCII, which is nothing but human readable, which means if you understand the architecture or the design messaging structure of HL7 message, you can read it. You cannot just look at it and understand what HL7 is, how it is used and all. And it can work on any OS. It is completely operating system independent for the reason that HL7 is operated at the 7th layer, right? In the application layer from the OSI model. Every operating system will follow that OSI model architecture, and every operating system will have 7th layer. As HL7 is operated at 7th layer, apparently it is independent of the OS that we are dealing with, whether it's Linux, Unix, or it could be Windows or Mac or whatever it is. It doesn't matter. Then, as I said, it will connect from any application to any application. All that we need to know is how do we build HL7 interfaces between different applications using an integration engine. And obviously, it will give a lot of assistance with respect to access to overseas market. Different states can be interconnected with each other with respect to data to form centralized repository, where government will have access to a lot of data of all the states that they are dealing with in any country. It could be in any country. So why do we need this standard? So it is obviously pretty much clear that definitely we need some sort of standard mechanism for sharing the medical data. Not only with respect to medical data, in today's world, we see that there are standards with respect to a lot of other things. Medical data, I mean, having a standard in medical data is one of the aspect of it, which has been solved back in 1990s itself. So another thing is, if we have standards, we don't need to discuss about what has to be done with respect to claims. I mean, they don't need to discuss when hospital and insurance people are discussing with each other. They don't need to discuss what code has been sent, what procedures you have used, what kind of diagnosis code you have used, and all. They can directly go ahead and send in the standard format that the insurance company is expecting electronically. And obviously, it will these standards are enabling the applications to talk to each other. So when two or more applications are talking to each other, which is nothing but transmitting the data with each other, it is called as interoperability, as we are enabling the data exchange between different systems. Obviously, greater safety for the patient, because data is being stored, and data patient history is always available for the patients. In case even if they lose something, it is always available at the hospital, so that patient's data can be seen always. For example, a patient is some allergic to something else, and patient is in unconscious state and has been brought to hospital. Now, no one might know what is allergic to, but his hospital record will have it. So that is one kind of safety that we'll have. And finally, quality is maintained utmost with respect to the patient data or healthcare data when we are exchanging it in the form of electronic data exchange. So now we will see, now that we have understood what is history of HL7, how the name has come up, where do we use it, and what is the importance of HL7, we'll quickly jump little deeper into how HL7 messaging works. So this is where we'll be relating back to the hospital workflow. Now in the hospital workflow, we have seen that patient is visiting the receptionist desk, and after coming there, they are capturing the capturing basic demographic details of the patient. So demographics is nothing but the general patient data that we have seen. The demographic details are captured and they will be stored in the database. Now, when this interaction is happening, as soon as the demographic details are stored or saved into the database, this data has to flow over from the PM system to the HR system, right? Or else how the doctor will know that what is the name of the patient and whether he has insurance or not, or whether he has some guarantor or not, and what is his phone number and all. So at least the basic details and the name of that particular patient has to be known, and what is the age of the patient has to be known to the doctor. So that raises the requirement of data to flow from PM to EHR, right? If the data is stored just in PM system and the patient is visiting the EHR system, which is nothing but the doctor's desk, then there is no point. Doctor will not know who is coming, who is going, right? So the data that is stored or captured within the PM system and saved within the PM database has to flow from PM to EHR. Now we know from the previous slides that there will be an interface which is transmitting the data from PM to EHR. But there is one minute point here that we need to concentrate on when the data is being transmitted from PM to EHR. Let's say the receptionist is saving the data, capturing the data, and as soon as they capture the data, they click on a button called as save. Usually, whenever we have something on our phones, applications, and all, if you have to do something, we will save the data, right? So in the same way, patient's details will be captured or inserted into the database upon a trigger called as save. When they click on save, that is when the data will be saved or inserted into the database tables. So when that happens, that particular point is called as a trigger event. HL7 mainly works based on those events. So now patient is coming in, he has got his details registered. That entire um, conversation or dialogue exchange that is happening between the patient and the receptionist is called as a event. So that event is generating some sort of data, which is nothing but the patient data, and that data which is being captured during that event has to be flown over to the EHR. And what is the trigger for it to flow? Saving that patient details. Clicking on save is the trigger for it to flow from PM to EHR. So this plays a major role in terms of HL7. Now, as soon as the trigger event is generated, so that particular event is called as a trigger event when the data has to flow from PM to EHR, or the trigger or the starting point when it says that data should go from PM to EHR. As soon as that trigger is generated, the message that is stored or the data that is stored will be converted to HL7 and that will go to EHR. So there could be many events that are happening in the hospital. Receptionist, I mean, discussion with the receptionist, getting their patient details stored is one of those events. Now you will have appointment related event, you will have charge related event, you will have observation related event. So there are many events in the hospital workflow. So each of those events will generate the necessity for data flow from one system to another system. So that is the main core of any HL7 message that is being generated. So There are many events, as I said, when we broadly discuss about those events. Their registration is one kind of event, appointment scheduling is one kind of event, lab is one kind of event, and charges are one kind of events. Pharmacies and related insurances are another event. So all of these events have uh, their own structure in the form of HL7, which we'll be taking a look at in the next session. But in today's session, we will limit to understand what all these events are. So these are the events that we have broadly categorized. I'm saying broadly, which means they are again divided into many other sub events, which we'll be talking about tomorrow. But these are broadly categorized into these events. So now someone has a question?
Yeah, hi, this is Sri Devi.
Yes.
I want to know what are the prerequisites for learning HL7? I'm completely new to HL7 messages, so what do you think is the prerequisites for that?
So prerequisites would be, so you for learning HL7, you don't need any prerequisite, but to implement HL7, you would need some prerequisites. HL7 is
Right.
learned by business analysts who are who don't even deal with technical aspects, but to extract data from database and generate HL7 messages, you would need to know SQL. Other things we are covering in our course itself. So you need to know basics of SQL so that you know how to write a select command to extract data from database. Other thing that is
Okay.
needed is JavaScripting. JavaScripting, so we have 2 sessions on JavaScripting where I will be teaching from the basics of JavaScript uh, to the extent that is needed for Mirth Connect implementations or to create real-time interface implementations. So that will be taken care during the course.
Okay. And in my company, they are using Ensemble. So how's the Mirth Connect and the Ensemble, work-wise, both are same, or what kind of difference they both have?
See, so the basic logic remains same, how we implement and how to create an HL7 message. Extract the data from database and you go ahead and construct the HL7 message using transformations. Even in Ensemble, we'll have transformations. Usually interfaces on Ensemble are called as productions, and we'll be able to build some transformations in Ensemble. The way we build the transformations in Ensemble is different from Mirth Connect. And if you talk about any other interface engine, it will be different. But the logic remains same. The mapping concept of uh, mapping the data that you're extracting and mapping it with the HL7 fields and components remains same. But all that you need to know is how that application has to be used to perform this particular action.
Okay. And one last question.
Sure.
Suppose the labs are sending the documents or the result in a document back to EHR. Can they do it in HL7, or do we need something else to handle the documents?
So what kind of documents? It depends on what kind of documents we are dealing with. Are they PDF
The
files
results.
or yeah, then if it is just the results, then yes, we can definitely do it in HL7. If they are images, then we have to do it using a different standard called as DICOM.
Okay. And what is CCDA? Where exactly the CCDA is used?
CCDAs are used when we integrate with HIEs. So we'll be shedding more light on that in the last session of our training.
Okay.
So they are also
Yeah.
documents. To brief, they are also documents, but they are not used for regular data transmission between the hospital systems. They are used to share data with a central repository.
Okay. Okay, that works. Thank you.
Yep, sure. Any other questions from anyone? We can halt for a while for questions and then we can.
Dixon.
Yeah.
Hi, Dixon. This is Deepak. So, just to clear the fog that so I've been working as a healthcare analyst for like 3 years now, and I had this inclination of getting into HL7, but I'm just a functional healthcare analyst. It's like more of the functional side, and I'm not that aware of the technical stuff. So until which part of the, because I understand fully that an analyst should know everything about the HL7, but again, which specific part would be the focus, and then which specific part would be the lesser preference? Is that something like that, or you have to prioritize something?
Yeah, you can definitely prioritize. So at least you have to know. So what we are going to cover is the basic stuff and generic stuff, which has to be known for all the HL7 interface analyst. So from interface perspective and from HL7 perspective, you should at least know what are the events that are part of registration, appointments, and charges and labs. And there are advanced message types as well, like MDM message type. You will talk about other pharmacy related message types, and you will also have few other query response related message types and immunization related message types. So there are many other message types as well, but this is the basic and generic stuff which covers almost 70-75% of the implementations out there.
Okay.
So are we also going to cover the MDM and the immunization messages in the class?
Immunizations, no. MDM, yes.
Okay.
Thanks, Dixon. Yeah.
You're welcome. Any other questions from anyone? All right, so we'll continue. So now that we have understood what is HL7, where we use it, and what is trigger event, which is actually generating an HL7 message. Trigger event, we can say that it will give birth to an HL7 message. So trigger events are many kinds. We have broadly seen the categories into registration, appointments, and all. Each of these events that are happening will generate one HL7 message each. So now we have to understand what is the anatomy of an HL7 message. So few of them might know what is HL7, few of might not know. So I'll consider from base, and we'll see what is the architecture of any HL7 message. So we'll quickly look at one small example just to understand and relate it to how HL7 is architected that way. Let us say we have two different people in a house, and that house has a rack, and it has three different shelves. Each of the shelf is dedicated for certain things. Now we see that first shelf is dedicated for putting the clothes, second shelf is for books, and third shelf is for some electronic items. Let's assume that. And when you see there in the first shelf, it is again divided into different compartments. It is first compartment is storing t-shirts, second compartment is storing trousers, and third compartment is storing shirts. Now everyone at home are already aware of this particular design. They know that first shelf of first compartment will always have t-shirts, second compartment will always have trousers. Now one of the guy is going out, and all of a sudden on the way he realizes that I did not get my t-shirt, or he's going to some tour or somewhere, and he calls his brother at home and says that, can you get my t-shirt? Brother will go pull the t-shirt from the rack, or pull the t-shirt from the first shelf or first compartment, and he will go to the station or airport and he will give that to him. Now when they have exchanged the dialogue between them, he did not tell the address of where to get the t-shirt from to the guy who is at home, but the guy who is at home just went to that particular rack, he pulled out the t-shirt and he went and gave it. How did that happen? Now we know that because of the reason that everyone at home knows that this particular architecture, and they know that the first shelf or first rack will have first shelf or first compartment will have the t-shirt. He has picked up the t-shirt and he went and gave it. Similarly, we have many other examples. As soon as there is a power outage at home, what do? We just try to reach out for our candle. I mean, in today's world, we are obviously reaching out to our mobiles, but in earlier days, we used to reach out to our candle. Even if it is dark and darker enough, you just navigate to the place where it is stored, because we know for the reason that that's a dedicated placeholder to store the candle and the matchbox. Same when we look out for keys, even if we close our eyes, we navigate to that particular place for the very same reason. HL7 also work on very similar principle. Okay, When we are capturing the data at the front end, we are capturing data elements or data pieces. Now, when we talk about name, name is one data element. When we talk about capturing email address or phone number, we are capturing data, we are capturing those as individual data elements. And these individual data elements have certain specific placeholders in the HL7 message structure. So even to understand where we store what, first we need to understand the architecture of that particular rack, right? If we want to know where we have to store t-shirt, where we have to store trousers, to decide where we have to store what, first we should know what is the architecture of that particular rack. In the same way, first we will see what is the structure of an HL7 message. Then we will try to understand what data elements are stored at which component of that rack. So any HL7 message is basically divided into segments. You can compare the segment each shelf that we have seen in the previous example, and uh, each segment is again divided into fields. Fields are nothing but the compartments of that shelf. You can say that we have each message has a segment, has one or more segments. It will definitely have one segment for sure, and more than one segment is always seen in terms of HL7 message that we are transmitting. So we have segments, and segments are again divided into fields. Fields are nothing but individual compartments. Fields are again divided into components, and components are again divided into subcomponents. Okay, fields are divided into components, components are again divided into subcomponents. In this way, an HL7 message is divided into tree-like structure: segments, fields, components, subcomponents. So as of now, to understand just HL7, don't worry about the lower elements, which are nothing but subcomponents and components. Now we will concentrate just on segments and fields. Okay, so let us take a look at the architecture and the segments. Before that, as I told you in the earlier slides, HL7 messaging standard has its own grammar and syntax. So we will take a look at what is the grammar and syntax of HL7. So while writing English language, we have seen that we know full stop is to terminate any sentence. Comma is to give a gap or give a pause to the sentence while reading it. And we have other grammatical expressions that we have. Similarly, in terms of HL7, we have something which we can compare to our English language. So segment terminator is nothing but kind of a full stop, which is going to terminate each segment. And HL7 can have in many number of segments. We have seen in the previous slide. An HL7 message will have is nothing but a combination of many different segments. Each segment has to have an end. So each segment will be terminated with a segment terminator. So this is called as CR. CR is nothing but carriage return, which will actually say that that's a full stop for that segment to end, for a segment to conclude. Next, we have field separator. Field separator is indicated with the help of the symbol called as pipe that you're seeing here. So a pipe is nothing but a compartment separator. You can compare it to a compartment separator. It is going to separate two individual compartments, and each compartment is called as a field, and it will hold certain type of data, which we'll be seeing in the next slide. And then we have component separator, which is indicated with the help of caret. This is called as caret. The cap symbol, we call it as caret, and it is going to separate two components. And we have subcomponent separator, which is ampersand, and repetition separator, which is nothing but inverted S. We call it as a tilde, which is used to separate two repetitions. We'll be looking at example of each one of these. Don't worry about it. First, just understand that we have these symbols which are going to be used in order to express an HL7 message. So finally, we have escape sequence. So we have escape character or escape sequence that can be said as it is a backward slash, which is used to escape certain data elements soon after the escape sequence that we give in the HL7 message. So now let us take a look at one sample HL7 message to understand it better. So this is how an HL7 message looks like. So the entire data, demographic data that is captured in the front end, like patient name, date of birth, gender, SSN, his email address, his mailing address, and all of that information is in there in this HL7 message. So the data that we are capturing is converted into HL7, and this is how HL7 message looks like. We have seen the architecture. Each HL7 message will have one segment. Each HL7 message will have segments. It could be combination of one or many segments. Here we are seeing that we have 5 segments. This is 1, 2, 3, 4, and 5. There are 5 segments in this particular message. Now, when we are looking at the example of rack, we said that we have name for each rack. First rack is for clothes, second rack is for books, third one is for something else, and so on. In the similar way, each and every HL7 segment will have its own name. Okay, as we can see here, if you observe the beginning of each segment has a name: MSH, EVN, PID, and they are nothing but acronyms. Each segment has its own name and each acronym has its own full form. MSH is nothing but message segment header. EVN is nothing but event segment. PID is nothing but patient identification segment, and so on. So don't worry about remembering them now. We will take a deeper look at them later. So we will concentrate now on PID to understand and to explore what are component separators, what are field separators, and all. So if you look at PID, this is PID segment. PID means patient identification. So as the name itself suggests, it is going to identify patient related information. Okay, so let me open one sample HL7 message and show that to you in Notepad so that we can navigate through it. All right, so we have this as an HL7 message. So as I said, each HL7 message will have each HL7 message segment. This is segment number 1. So let me divide that so that it can be very evident and clear. Okay. So this is EVN, which is second segment. This is PID, which is third segment. We will zoom into PID segment and we'll take a look at it. But just see at the end of each segment, this is MSH segment, and at the end you have CRLF, which is carriage return line feed. So this is going to act as segment separator or segment terminator, you can say. Okay, and then you have individual segments. So there are many segments that we are seeing here. This HL7 message has PID, PV1, GT1 has guarantor information, IN1 has insurance information, and all. So I will remove all of this. I will just pull out PID so that we can explore PID. So let's take a look at PID now. So in PID segment, I told you that pipe is a field separator, which is nothing but each compartment in the shelf is divided into different compartments with the help of a separating wall between each of them. So pipe, you can assume that it's a separating wall for each field. So this is called field number 1. This is called field number 2. So all the fields are given a number starting from 1 to how many 1 to depends on the number of fields that that particular segment has. Now here you are seeing that there are many data fields. So this is field number 1, this is field number 2, this is field number 3. Till here it is field number 3. Field number 4 is blank, field number 5 we have some data, and so on. So in real time, whenever we want to go ahead and navigate through HL7 message, we use the navigation with the help of segment name. And then we provide the field number and then the component number. So forget about component for now. Don't get into component number as of now. We'll take a look at that at later point of time. So for now, we will just call the segment name and call the field number. So now our segment name is PID. We know the numbers. PID1 is nothing but the set ID, or you can say it is a sequence ID. In real time HL7 message, it is called as set ID. We'll discuss more about that. For now, just remember it as sequence ID. Then PID2, we have some ID information here. You have this, right? This is called patient ID. Next, we have PID3. PID3 is also patient ID or MRN number. We will talk about the differences later. And then PID5, 4 is blank. So PID5, we have name. In this way, there is a lot of data in here. Okay, but if you observe, each data element that is held between two pipes is called as a field, and each field has a number, right, starting from 1 to depending on the number of fields that we have. So it will be a sequence, and I just told you that with an example. We know we have certain placeholders for certain tools at our home. In the same way, in HL7 there are dedicated placeholders or dedicated fields for each kind of data that we are dealing with. Now, PID5 has name. It means that PID5 should always have name information only. PID4 is blank here. That doesn't mean that we can put our name information there. That is what HL7 is all about. HL7 messaging standard clearly defines which segment should be used for what kind of data, which field should have what kind of information in it. Okay, HL7 clearly tells PID5 is dedicated for name. So if you don't have information regarding the name of the patient, don't fill it. I mean, don't have any data in there. Okay, if you have the data, then put that data in there. If you don't have the data, you go ahead and leave that particular field as blank. Okay, that is what HL7 is all about. Now that we have seen what is segment, what is field, we will just take a quick look at what is component. Let us zoom into PID5 and see what is a component. Now, when we talk about name, as a whole, this is name, right? PID5 is dedicated for the patient name. But when we talk about name, we have many things that will fall under name. We have first name, we have last name, we have our middle initial, we might have suffix or prefix like senior, junior, and so on, right? So there are many elements of a name that we might have to consider. So if we have our first name and last name, let's say we have Michael John, this is his first name and last name. In PID5, we cannot just go ahead and give it as first name and last name. These two are called as components of a name or components of a field. And we know that components can be separated with the help of a caret. Okay, so if a certain field has one or more components, those components are separated with the help of a component separator. Okay, so this is a slight structure of what HL7 message is. And now that we have understood the structure, we will take a deeper look at all of these individual segments in the upcoming sessions. So any questions with the structure of the HL7 message?
I have a question. What is the data type here?
Data type is nothing but, so let us say PID5. PID5 has certain data type in terms of HL7. So HL7 has defined what kind of data has to go in which kind of field. When it defined what kind of data has to be traveled, it also defined what should be the data type of the data that is going to be traveled in each one of the fields. So we have two separate sessions in data type where we'll be exploring more about data types.
Okay.
So what is the repetition and escape character? I don't see them here.
In this example, we don't have it. We'll take a look at the example when we are looking at segments individually.
Okay.
Hi Dixon, my name is Danish here.
Hey, Danish.
My question is, yes, I think as you mentioned, there is a numerous messages getting exchanged between the application in the behind, right? So like I'm just trying to draw a comparison between XML and how its a schema is validated. In XML, we have a schema. Whenever we feed the schema and tell that, hey, this XML is a valid, it tells me that yes, it's a valid. Because as in my contract, we have established a contract. I mean, here in the space of HL7, I mean, you mentioned already that you have a specific placeholder and the fields to a specific information. So how do you validate? Because I have a contract with your application, my application. How do I say, yes, I think if I just feed that one and tell it, hey, it's a valid HL7 or invalid HL7 as per the contract? Can you give us some light on that side?
Sure, yes. So in terms of XML, you will be using XSD schema, right? So for validation purpose, we are going to build all of those validations in HL7 in Mirth Connect transformation engine. The reason why we do that is specifications are not confined to or not standard all across the hospitals that we have. So when we are talking about implementations, um, in terms of XML, you define certain XSD and you say that this is a schema that we are going to use for certain location or certain integration that you're performing. In the same way, when we are integrating between one hospital and one lab, the schema definition between them could be different from some other lab that they are implementing an interface with. All of these definitions and validations with respect to that schema will be done in Mirth Connect transformations. So when we are extracting data from database and building an HL7 message, we will keep in mind whether that schema is being complied or not. We will comply to that schema and then we will build the specifications. Even after we'll build the HL7 message, even after building HL7 message, we will be writing a transformation logic which will validate that HL7 message whether we are complying with that specification which we have decided with the vendor or not. So that is done in Mirth Connect.
Thank you.
You're welcome. All right, so I'm not hearing anything, so we'll jump to the next slide. So training and certification in HL7. So HL7 certification can be done, anyone can do it. So you can do either by self-study or you can attend seminars and you can attend webinars and you can get it done. So you need to read up all the chapters, but questions will fall as part of chapter 2A and chapter 2B. So there are many chapters as part of HL7 2.8 version. So currently HL7 organization is providing certification on 2.8 and version 3. But we are this training is all about version 2. So version 2.8 is what they are currently providing the certification for. And as I said, there are many chapters, but you need to concentrate mainly on 3 chapters from where the questions will arise. And certification is done by HL7 organization. Each country has their own organization board who will release those certificates. So they are the only authorized body. There is no other one who can provide the certification. Exams are held regularly all over the world. Another fantastic option is you can write it from home. So they will install some kind of software, I guess, but you can write it from home. And then who can get trained in HL7? So from basics perspective, all the managers, healthcare integration specialists, whoever is dealing with healthcare data and all can be trained. And programmers in healthcare applications will definitely need to get trained. And doctors and paramedics who want to know about HL7 can also be trained, and IT administrators. And for intermediate level, programmers of healthcare applications for sure, and doctors and paramedicals. So when we are dealing with real-time implementations, we see that many doctors are also joining the meetings. So even they do learn HL7. So IT administrators for sure, and experts, obviously, whoever is dealing with programming the interface or developing the interface should learn, and healthcare IT domain experts should learn it. So to summarize, as we have seen, HL7 is mandatory for interoperability in case of healthcare applications. There is no other way as of now. In order to transmit data from one system to another, we have to transmit it in the form of HL7 itself. And obviously, it is becoming an unescapable requirement. If, all over the world, we are seeing that HL7 is being used for healthcare IT implementations, and definitely a selling point for many vendors. If their certain application is HL7 compliant, then their application will have an upper edge to be bought by hospitals. And HL7 is mandatory for sure. So it's better to learn HL7 as soon as you can. Just not from language perspective, but also from um, integration perspective. There will be, I mean, job profiles are based on both of them. There are few business analysts who just know HL7 but don't know how to implement an HL7. And there are integration developers who know HL7 as well as they develop interfaces with respect to HL7. So there are many job profiles out there, and this will definitely lay foundation for you to learn FHIR as well. FHIR is just an enhanced version of HL7, you can say. All the data elements that you see in HL7 in each segment is basically converted into a resource. To put it in a very simple way. So you will be able to learn FHIR as well once you learn HL7. So that concludes our today's session here. So we will see more on it tomorrow. So any questions from anyone?
Yes.
Sure.
Just to ask for the certification, you mentioned that HL7 has 12 chapters, but you mentioned that the exam will come from the chapter 2. So why
Right.
do we need to read the other chapters?
I mean,
Is there
honestly, if
something
you are
that will come?
preparing only for certification, you can just look at chapter 2, chapter 2, and chapter 2B. Those are the 3 chapters which you'll get the exam from. But to get more knowledge on how implementations are done, you can go through it, but it is not necessary.
So for sure, the exam will not come from other chapter if I want to
No.
just for certification.
Yep.
Okay. May you share with us this recorded session for today for our reference
Yes,
by
yes.
email?
Yep, yep. We'll do
Oh,
that. And by the way, oh yeah, I mean, once all questions are done, I would like to capture email addresses of everyone. Yeah. So any other questions from the team?
Is there a complete hospital workflow that you would be sharing? Starting from integration with PACS and dictation software and all that on the different
No.
HL7
Yeah.
segments?
So right now, see, PACS integrations is completely different. We'll be using DICOM messaging structure for that, and that's again another messaging standard. So our training will concentrate mainly on integrations using HL7. So this is where we'll be discussing about what kind of HL7 message is used in different kinds of events. So from HL7 perspective, we'll be covering 70% of the real-time implementations. Other 30% would include VXU message types, MDM message types. MDM we are covering anyway, but there are few unique message types which are not frequent. So we won't be looking at them, but 70 to 80% of the hospital workflow where HL7 is involved is already covered through this training.
Okay. The reason I was bringing this up is there's a lot of workloads that gets associated with the PACS, and
Yeah.
with the AI coming in place, there is a lot of worklist prioritization which involves HL7. So I was just asking about that.
Absolutely, absolutely. I understand. So yeah, workflows play a major role. Without understanding workflow, we won't be able to proceed with the implementation. And as you said, in real-time implementations, workflows are a lot based on the hospital's architecture, again, hospital's workflow.
Okay.
Dixon, I have a question.
Sure.
Just can you give me the overview of like how the course will be, in the sense you mentioned about Mirth. I think that this is the basic what you covered for today's session.
Absolutely.
And what is the next step? I mean, what are the things you're going to cover? I think you mentioned
Sure.
around 70% you cover for HL7. Can you split on it, and how many
Right.
hours you will be covering, and what is the timings? I think if you give a little bit more information in detail, it will be quite helpful.
Absolutely, absolutely. So let me just pull out the course curriculum. I'm not sure how many of you have got it and how many of you have gone through. So let me quickly cover that. So this would be our course curriculum. We'll have around 25 to 30 sessions. So that depends on the reason why we span it between 25 to 30 is while going through practical sessions when we are implementing, when we are seeing real-time implementations or when we are developing it, few sessions might spill over. So that is why we set it to 25 to 30. So it will include, in today's session, we have seen healthcare messaging standards. In tomorrow's session, we'll be seeing what are the basic concepts and principles of how do we generate message events, what are the different events uh, in terms of real-time hospital workflow. How do we name them in terms of HL7? So we will be seeing them tomorrow. And after that, we'll be seeing how do we build HL7 messages. So I have given a detailed description in the individual, what are we going to look at in the individual sessions in the course curriculum. We will share this anyways. In sessions 3 to 7, we are going to look at what are different message types that we have: ADT, SIU, DFT, ORM, MDM, QRY, and ACK. And then we'll be seeing what are the building blocks, which are nothing but the data types. We'll be having 2 sessions on data types. There are 90 data types, but covering everything is not possible. So we'll be covering around 30 to 35 data types in these 2 sessions. And after that, we'll be starting about Mirth Connect integration engine. So we'll be taking a look at Mirth Connect interface engine. We'll have an application tour to see what is the architecture of Mirth Connect, how Mirth Connect functions, and what are the various options that we have, what are the various tabs that we have. In order to build an interface in Mirth Connect, we first need to understand the application completely. So we'll be going through what are the various concepts that we have from application perspective, and we'll be seeing how do we build uh, various kinds of various kinds of interface using different connectivity types. And we'll be taking a slight overview of networking, because networking holds a major role as we are talking um, exchanging data between 2 different systems. In what form we are exchanging? Is it through TCP/IP, or is it through folders, or is it through SFTP? What kind of connectivity type that we are using in order to exchange the data between the systems is necessary. So that we'll be going through basics of networking for sure, so that we can understand what are the connectivity types that are supported and that we use. And we will also be taking a look at, and after that, we'll be taking a look at creating channels. How do we create channels? And all of those will be practical sessions. So we'll be seeing channel creations in various forms. We'll be seeing TCP/IP implementation. We'll be seeing folder implementation. We'll be seeing database implementation. How do we extract data from database? How do we generate HL7 message using the data that we are extracting from DB? How are we interpreting data from an HL7 message, and how do we insert that into database? And finally, we'll be taking a look at XML and E4X, and also basic programming language for JavaScripting, which is necessary to build additional transformations in Mirth Connect, which are done in filters and transformations. So we'll be looking at those as well. And then we'll have few assignments for 1 or 2 sessions based on if I'll give you the assignments, if you're doing it well and good. And if you have any questions, we'll be having 2 sessions for discussing about those assignments. If you have any questions, or else we'll skip those sessions. And in the last 2 sessions, we'll be talking about HL7 certification. How do you prepare for it? What are the chapters that you have to go through? I've given you the brief that we have to go through chapter 2A, 2B, and 2C. Chapter 2, 2A, and 2B. We'll be exploring a little bit on chapter 2B. After going through HL7 messaging structure and data types, you will understand how to prepare for chapter 2 and chapter 2A. But 2B is something that is called as, that will include everything about conformance. So I'll be talking more about conformance during that one session. And in the final session, we'll be talking about, we'll have a bird's eye view of what are the other standards that we have of CCDs, FHIR, and what is MU. And we'll take a look at them. I'll show you what is CCDA, what is the message structure looks like, what is the XML message, and what are the components of that CCDA, how sections are individually divided. I'll give you brief explanation on that CCD, so that when you look at the actual specification, you don't get it doesn't fresh new to you. and we'll be talking FHIR as well, why FHIR has emerged, what is the main advantage of using FHIR, how it is useful in healthcare industry as part of meaningful use 3. So we'll be taking a look at that as well, and we'll be taking a look at what is HI, how do we use HI, how is it useful and all. So in the last two sessions, we'll be talking about that. So this is a course overview, and as I said, we'll have it from 25 to 30 sessions, and we'll be sharing with you all. We'll share this course curriculum with you all. Okay, Darnish, is there? Do you have any questions from that?
This is clear. A few more questions. It pops up as you answer. Questions will always pops up. The first thing is which Mirth channel version you will be training us. You'll be guiding us.
So right now, 3.9 is running in the market.
Right.
So we'll be, yeah, I mean, there is no much change with respect to how we build. I have 3.8 on my system, but both of them are pretty much same. There are not much changes in 3.8 and 3.9. So we'll be going through any one of the versions. So you can install 3.9 and work on it by using the same principles. Principles remain the same and the basic concept remains the same that we are going to take a look at.
Okay. What are the timings? I mean, because the session today you started at 7. Usually for all the session you will be planning with the same timings, or you going planning for
yes, every day we will have it from 7 to 8 in the morning. Usually it's a 1 hour session where 50 minutes we'll be discussing about I'll be training you, and last 10 minutes we'll spare it for questions and discussion about those questions. Today we had a little longer. I joined 10 minutes late, and we have many people with many different questions. So, but it is usually 1 hour session every day.
So,
and we will be sharing the recordings. We'll be sharing the recordings every day. So if you miss any session on one specific day, then you can go through the recording. A recording will be uploaded in 2 to 3 hours after the session is done. So you can go through that at any time. And it is 5 days a week session, right?
Thank you. The information is very informative. I think really I liked it. Thank you.
Sure. Thank you. So can you all just provide your email address in the chat box? Just type it quickly. We'll send the course curriculum, and you can join tomorrow's session as well.
The chat is disabled actually.
This chat is disabled.
All right, just give me 1 minute. Let me quickly enable that. Hello, Srinivas sir, are you there? Srinivas sir? Hello? Just give me 1 minute, guys. I don't think I have the admin rights. Hello, sir. Can you enable the chat so that all can provide their email address?
Sir. Yeah, I'm doing. And screenshot. Okay. Yeah, guys, you can pin me your email IDs.
So Dixon, I have a question.
Sure.
Yeah, so every day 7 o'clock means every day at the same time the session will be there.
Right, Sumit.
Yes. Okay. Thanks.
7 to 8 in the morning. So I think I'm not sure. Not sure about the timing, but you can attend tomorrow's session as well. And if you like, you can enroll for the session. You all guys, whoever want to go ahead and continue with the training entire course, you can go ahead and enroll for it tomorrow.
Yeah, sure. Thank you.
And